Right, thank you, David. Thank you to the ISRUP team for inviting us to give the talk. Crack on with it. We've got far too many slides as always, so I think we'll race through the early stuff and we'll concentrate on the really cool stuff, which is Arthur's. Right. About us, and we're also cool. We're format engineers. We're a small practice which grew out some of the larger practices in the UK. Our work is shot through with the use of digital technology, and this may be mentioned several times, but digital technology allied with first principles thought, lots of hand sketching, and going back to basics. So we're strong believers in the use of digital technology, but in a very sort of humane, sensible context. So there's a structure that we did in northern Norway, in Hammerfest, timber cabin. We've recently finished this research project with the University of Innsbruck, an older project, a bent active timber grid shell, and the University of the West of England. A more recent project of an extremely large work of art being delicately lowered into position in Wigmore Street in central London. Increasingly larger and larger scales, so this is an important point for us. We use digital technology to help us design and analyze extremely complex works of art or funky shapes, but actually we're quite passionate about applying this to the everyday as well. So this is a power station, or waste energy plant, sorry, outside Swindon. We're working on a 43-metre work of art in Marble Arch in London, and we also do increasingly non-structural projects. This is a facade of a listening pod for the BBC, where the first words ever spoken on radio were encoded as a series of pixels, and then we took that series of pixels and applied it to the facade on the behalf of the architect. So that's a small snapshot of us.
My turn, I guess. So we're architects, but not only. We have a Fab Lab, so I think it's quite a different way of working than a large office that would have one activity. Ours is several companies, and it's also so it's a Fab Lab, an architecture studio. I teach at University of Westminster, and I take students to build structures of their own, and then we develop a bit of software that allows to work with machines. The amazing talk previously talked a lot about the future of offices. This is our studio. The first floor is a workshop. We have a giant WASP printer on which we test different kinds of G-codes. This is some of the work we do with the students, and we bring them to the desert to build these kind of experimental structures that are a bit deregulated, which is very different from in London. This is let's say an apartment we did in London in the south. So it's an interesting dialogue between what one could call real architecture and the more experimental aspects of the machines, and how we develop a new kind of digital craft with the machines. Often, I started building a small rep wrap when I started my company 8 years ago. That's my first task, and everyone was like, "Why are you doing this? This is not architecture." But I knew that the technology slowly would get bigger and bigger, and that we'd need to understand how to, let's say, work with the machines and how to send the right code to them in order to develop an architecture that works in relationship with these tools. So this was how I sort of got to know format a little bit, and we'll explain our relationship, which is, I guess, an interesting story of an architect and engineers, I suppose. This is for Burr Apple. It's their headquarters. This came just after doing a shop window for Karen Millen, which you actually saw, I think, and called me at some point, which is interesting because the idea of scale, in a way, doesn't quite matter. It's more the approach here that brought us together, I suppose. So this is a very simple, flat, laser-cut plywood sheet, very cheap. And just by adding some springs to it, we could create these sort of highly sophisticated ceiling in the interior of Burr Apple Engineering, made from 3 modules. And the modules would be then bent in order to achieve this ceiling, which was both a a light diffuser, sound absorber, and just kind of an identity for a practice that deals a lot with wood. This is Burning Man and how we can use also sort of very simple materials and try to maximize them with the computer. This is called tangential dreams because it tells the story of the curve through straight lines. But it also is people writing down their dreams on those tangents. Format helped us a lot. They were the engineers on the project. And in the computer at the time was just like lots of lines floating in space, namely these ones. And then they helped us define how to kind of like position them on these shifted timber that would actually allow us to create the tangents between them. This is a project we're developing, a Polybot, which is a cable robot, all made in our studio with our printers, our lasers. Basically, because we're scaling up, we're trying to scale up the technology to I guess what one would call more architecture, although in my mind it's just a continuation of the small RepRap. It's the idea, this was with Arup. Arup helped us finance this tool. It was in their headquarters. And it's the idea that potentially building could grow and ungrow, and that we don't have to build finished projects and have empty spaces when a crisis happens. Maybe we can rethink that and have these blocks that are accumulated and then could potentially be unstacked, just like where we are, which is a Containerville. This is where our office is. So I'll continue on the shared history, right? Past Karen Millen, I think Stephen, his office was next door, and then said, "Oh, that's an interesting computational approach," and was contacted by some fancy space sort of tourism company, and asked us to work on a hotel for the astronauts, as you do. And so this is Recursion, and it's the very simple idea that you could throw vectors in space and then make them continue their journey by moving and kind of going one way and letting the loop generate these very natural Fibonacci type shapes. But the idea was to create a sort of obviously a galactic reference for the astronauts to come back, but also a space for people to congregate and have a common experience before they go to space. In parallel to that, we started going to Burning Man and started the collaboration with Format. Burning Man is a city temporary city in Nevada, which has art in its center. And we started developing all these geometry, going from kind of complex sort of laser cut, digitally fabricated, to a simpler use of off-the-shelf timber, and learning from the difficulties of building in the desert with a lot of students and also people from different fields. The adventure led us to this project, which we'll tell more about later on. We just, in my mind, I just came back from this, but it was September. This was a 60 meters wide, 20 meters high temple in which people would have spiritual experiences, which we'll describe a little bit later. And I look a bit tired, and I must be a bit funny when I talk, because we're going tomorrow to build this, which is a gigantic 30 meters long 3D printed project, which we're building here in parts and also in Milano for the Salon del Mobile. And it's made of these sort of bio-brick made of timber, 3D printed, a mix between PLA and timber. And so that's going to be quite exciting for us.
Okay, thank you, Arthur. So there's a lot going on. There's lots of projects. We can't show you because they're under NDA, etc. So we've learned to work together pretty closely, pretty fluidly, even though we're doing quite complex projects. So how do we collaborate? I mean, you'll hear that I don't know the level of expertise, the level of knowledge in the room, but we use a plugin for a 3D CAD package, Rhino, called Grasshopper, extensively, and all the various plugins that come. I mean, this has been mentioned about 500 times, I'm sure, but it is a fantastically powerful package. So we use that as our collaborate. I don't think we've ever worked on a shared classic 3D model before. in all the years we worked together, has always been on a Grasshopper script, and we fire the script backwards and forwards, and eventually it becomes almost indivisible who's done what on that script, which is quite an interesting way of working. It's almost Anthony Hunt's comment about, you know, indivisible who did what in the building sometimes, and I think it's the same interpretation of that. We collaborate so much. We have our own Slack channel, so our various officers can swear at each other and make jokes about each other, which happens a lot. And it's great. So we can swap ideas and information seamlessly as if we're sitting together. Again, I was banging on about hand sketches, and you know, the part of the Slack means we can sketch, we can throw these backwards and forwards, and these are all ideas that, you know, will eventually find their way into computation, but we're passionate shouldn't probably unless they're thought through first, or at least partly thought through first, hence the hand sketching. So, you know, that's, yeah, we don't want to lose sight of that. Lots of original research. We're both practices are very passionate about original research. This is research we're doing into harmonically stiffened grid shells that we're applying to an enormous project in the south of France, which we can't show you because it is strictly under NDA. So there's a strong thread of research running through our collaboration. Specifically, the tools that we use, Rhino, Grasshopper, we talked about that, fantastic. We make extensive use of a plugin for Grasshopper Caramba, which is a finite element plugin, but enables us to very quickly change Grasshopper models in the same way as Francis showed the Grasshopper model of the tower. We can knock out different solutions to that structure very, very quickly. We can look at the tonnage of the material. We can use all sorts of goal seeking, to morph the structure to make it even more efficient. So it works within the ecosystem very well. We developed our own structural analysis plugins for Grasshopper as well, called K2E, which enables us to look at very filigree structures, bent active structures, to look at the stress that's in bent active structures, and to look at the levels of exactly how much it's bent. So there's a lot going on, and there isn't really a slide for this other than the same slide which Francis showed, actually, which is, why does this work for us? I think the reason it works for us is, there is a danger of this visual spaghetti. There's horrible stuff. If you don't work closely and you're swapping models around, if you presented with this model, you look open and you think, I can't work with this. So being able to work so closely, having ground rules about who does what in what part of the model, and who contributes, it's very clear, and being able to explain it on Slack means that we don't often get this. Sometimes we do, but we don't often get this. So I think also these tools help us to explore more, deeper, and do, frankly, more interesting things in terms of least material, more complex forms, but also rationalize very simple forms as well. So it's further better, as was the cliche, which I think is true. So I think we want to summarize this partnership up in the story of one of the most recent projects, Galaxia. So over to Arthur.
Thanks a lot. So Galaxia is a project that we feels like we just finished. It was this summer in August inside the Burning Man city. You can kind of see the edge of the city and the sphere by BIG that is just out there. So it's very far away from the city, and it's a place of contemplation. People leave their bikes on the outside and come inside this central space in which there was a sort of contemplation space with mandalas and so on. It's a very special place because it's a spiritual space without any religion that brings everyone together around just grieving or just the idea of writing something about your past and letting it go through the act of burning. At the end, we burn the temple. It's a ritual. And so these are some of the images. It evolves all the time. I think the idea of ego dissolution can come in as well here in that this project is a sort of bare lattice that people write things on and sort of voluntarily, positively sabotage or in that sense. And so there's something about it being a very sort of emotional and poetic structure. As a Parisian, a bit like the Eiffel Tower in a way. It's a structure, but it has something very very poetic about it. So this is the bare essential of Galaxia. It's this sort of petals. It was rotationally symmetrical, learning from previous experience, that's important. And it's got a lower crown and an upper crown, and each module is made of these sort of folded, so it's built by volunteers. You got 140 volunteers building the project, and so it had to be very simple. And so it starts from the one-dimensional, the curve, then it goes to the triangle, then it goes to the module. And it's being folded in position. You can see the scale of each module. And this is us practicing in the numerous, the 2 Fab Labs we had in the US. These are the sort of thing we had to discuss. So we were constantly exchanging with format. Like, it's true, very hard to know who does what. At the end, we were just like, throwing ideas. Even the team, the 140 people, it became a bit messy because everyone would chip in with ideas and so on. But the metal fabricator, even the idea of the camp, you have to realize this is an entire village building this structure, almost like a cathedral, and all the builders are in there. And we're all in there together, the engineers, the scaffold people, the machine. And so we had this giant matrix of components to build and a clear sort of time-based schedule to respect. With this giant scaffold in the center that we had to work around. So thinking in 4 dimensions was extremely important. And this was some of the early analysis we had with format when everything collapses in the computer. So it's always better when it's in the computer. And I think the digital tool help us do this sort of empirical back and forth between trial and error. And that allows us to really evolve the system into minimizing materials and minimizing even the amount of screws. Because we are fundraising for the project, so we're raising about $600,000 in the meantime, which is not easy. And so any screw that we can save matters. And that's the kind of formula we received from Format, which was brilliant because we had all the kilonewtons. We knew the formula. So it's a very honest way of working in a way. And we help. So knowing Grasshopper, we can help use these formulas, and the boundary is not so clear anymore, but there's a sort of trust as well, because I suppose like we don't want to mess up. And so we would assemble these, well, I mean, we call them the bananas at some point. And they had all these metal plates with careful amount of screws depending on the kilonewtons going through them. We tried to maximize the amount of members in tension in order to have very thin members. And that's a trick that we reused on other projects, but the idea being that you have as little amount of compression as possible. And so this is the engineer. After building it, we all kind of transform into this kind of people. And so this was the project at the end, just before we open it. We were about to place the powder, the granite that prevents the burn from vitrifying the desert. And I think that's a little video that...
Yeah, so as you say, our engineer was so proud he put together a sort of video and insisted I put it in.
So the project is fairly simple in the sense that it's made of circles and circles on circles, which create these petals, on which we populate points on the basis of a graph, which is based on the golden ratio, and then this is being placed in the z-axis, and then it's we make truss from them. Well, it's going fast, and then the trusses are gone to Karamba, and then we kind of minimize the amount of kilonewtons going there, so that we have less thickness elements. So we only use 2x4 and 4x4 timber, and then we have these compression rings, which we...
Yeah, talk about it in a minute.
Yeah.
So,
there you go. We can
gratuitous engineering animations.
What was interesting is...
Next one's my favourite. This one.
Yeah. It wasn't so the transition from 4x4 to 2x4 to which module gets what, it was really fascinating because the computer told us that in many senses. So this idea of being critical, we're critical in the sense that we want to minimize cost and amount of material, but the computer does tell us some solutions that we had to be applied. So this was the burning. The structure was really also, we minimized the amount of material because we didn't want to waste too much wood. At the end, we burn it. And it's part of the ritual of Burning Man, and it's also a way of recycling all the steel, of taking everything down really quickly.
But it was also saying it's an interesting test of structural integrity in the sense that we had to add a couple of compression rings at the top to stop the thing spiraling in on itself. So the actual burn did show how the compression ring was working. There it goes, the compression ring collapses, the whole thing comes down. So that's basically us. Thank you very much.
Yes. Thank you.